So students, today we discuss the chapter electromagnetic waves. So in this chapter we discuss what about the electromagnetic waves, what is the nature of light, and last electromagnetic spectrum. So first we start with nature of light. So in order to understand the nature of light, there are different theories which we have already learned in previous classes. There are some different theories like Huygens theory, Maxwell theory, and third one Planck's theory of light. And if we talk about either Huygens theory, Maxwell or Planck theory, so all the theories go to wave nature of light as well as particle nature. So all the theories overall suggest that light sometimes behaves like a wave and sometimes it behaves like a particle. And this is the last one. Planck suggests that energy is to be discreted and it is to be found in terms of discrete packets or bundle, and the smallest packet, this is called E is equals to h nu, called quanta of light. So energy is not a continuous form, it always distributes in terms of small packets, and the smallest packet is E is equals to h nu. Here we also take E is equals to n h nu. That means integral multiple of h nu, maybe 1 times, maybe 2 times, maybe 3 times, and so on. So on behalf of this, we discuss electromagnetic wave. What is electromagnetic wave? So if we talk about the electromagnetic wave, so as we know that wave is to be categorized broadly in two parts. First one is mechanical and second one is electromagnetic wave. So waves, this is a kind of disturbance which may be classified in two parts, mechanical and electromagnetic. Mechanical means we require medium for their propagation. Okay. While if we talk about the electromagnetic wave, so we do not require medium for their propagation. So in mechanical waves we require medium like sound wave, water waves. So in all the waves we require medium for their propagation, but in electromagnetic wave we do not require medium. For example, X-ray, ultraviolet ray, okay, gamma rays. So all these waves do not require medium for the propagation. Now we see what is electromagnetic wave. So first I draw we required here three axes x, y, and z. So what we have to see in this wave, when I draw this wave, so in this wave E defines electric field vector and capital B denotes here magnetic field vector. That means if I arrange my left hand in such a way, first finger, second finger and thumb all are mutually perpendicular. So as per this diagram, if electric field vector, magnetic field vector and direction of propagation, all three are mutually perpendicular. Okay. So such kind of wave in which electric field vector, magnetic field vector and direction of propagation, all three are mutually perpendicular. So such kind of wave is known as electromagnetic wave. Okay. So there is an importance of electric field vector and magnetic field vector. This create a electromagnetic wave which do not require medium for their propagation. And as I discussed, there are so many examples: X-ray, ultraviolet, gamma rays. So on behalf of this example, we define one spectrum where we lie in electromagnetic. That as we know, we lie in visible region. That's why we see the object around us. So electromagnetic wave having one spectrum, and spectrum having some range, wavelength, frequency, and on basis of wavelength and frequency we define one spectrum. So next we discuss here electromagnetic spectrum. So now we start with brief study of electromagnetic spectrum. Okay. So electromagnetic spectrum consists of, number one is radio waves, number two microwaves, number third is infrared, number fourth visible, number fifth is ultraviolet vision, number sixth is X-ray, and number seventh is gamma ray. So all the seven, it consists of a spectrum. The spectrum means a series so this part is called here spectrum. So spectrum means here a series arrangement of all the waves. Okay. So if you look here, first starting with radio waves, then microwave, infrared, visible, ultraviolet, X-ray and gamma. So we all human beings lie in visible region, that is in fourth one. So we all lie in fourth one region, and this is our category. In fourth one part is here visible, and in visible we see the regular arrangement of colors. So V, B, Roy, Great Britain. So this is the colors what we have to see: black, brown, red, orange, yellow, green, brown, violet, green and white also. So all the colors we see in visible part only. Okay, and we have one short trick to retain all the seven series. Red man is violet, uniform with X gun. So here R stand for radio, M stand for microwave, I stand for infrared, B for visible part, U for ultraviolet, X denote here X-ray, and G stand for gamma rays. So via this a single line we can retain all the seven parts, and here order is maximum wavelength to minimum. So if we go to first to last, so what we have to see here, wavelength is to be decreased. So this is very important here. If we look the wavelength, because this wavelength is to be retained, this is important for exam purpose. So the order of wavelength for radio wave, this is less than 0.1. For microwave, this is 0.1 to 1 millimeter. For infrared, this is 1 millimeter to 700 nanometer. Here N stand for nano, and this is 10 raised to power minus 9 meter. Okay. Similarly for visible, 700 nanometer to 4000 nanometer. Okay, this is very important reason. Fifth one is ultraviolet, 400 nanometer to 1 nanometer, and similarly for gamma ray. So this is very minimum, greater than last 3 10 raised to power minus 3 nanometer. So this is the sequence for maximum to minimum, that is descending order of wavelength. And as we know, the relation between frequency and wavelength is inversely proportional. That means for gamma rays wavelength is to be minimum, that means its frequency is to be maximum. And similarly, if we go to first one, radio waves, so here wavelength is to be maximum, that means frequency is to be minimum. So this is very important concept, because in exam there are some questions. Arrange the waves in ascending order of frequency, descending order of frequency. So we retain this line and retain only one order. Wavelength is to be decreased if we go from first to seventh one. Next we come to how to produce the radio waves. So radio waves is to be produced via accelerate motion of charge. That means whenever charge particle is in motion, so it produces radio waves, and these radio waves are used in communication purpose. As we know, there are in communication we require ground waves, sky waves and space waves. So all the waves require radio waves for perfect communication. Similarly, in communication we require short wave, TV broadcasting, similarly UHF high frequency, VHF, FM. So all the communication in our daily life, it is only and only for radio waves. So this is the some practical uses what we have to see in our daily life. Second, we come to microwaves. So we all microwaves are generally used in our kitchen also. So microwave oven, this produce microwaves. Okay. If we talk another name, so microwaves to be produced by klystron, gun diode or microwave oven. So all such kind of hot bodies, this produce microwaves, and its practical use in ovens for radar technology. This is very important. Similarly for aircraft navigation. So this is too important practical use for microwaves. If we go to infrared, so infrared rays are to be produced by hot bodies. So whenever object is to be hotted, maybe in terms of heat radiations or in electric field, so these hot bodies produce infrared rays, and these infrared rays harmful for us because we lie invisible. So except for this reason, if suppose radio waves, microwave, infrared, ultraviolet, X-ray and gamma, so all the rays harmful for human being, because the order of absorption of wavelength is for us 700 nanometer to 400. Beyond or more, wavelength is to be harmful for human being. Okay. So infrared is to be produced by hot bodies, and if we talk about the uses, so preserving food. If we go to pizza center and any restaurant, so we see how the food is to be preserved for a month. Okay, 6-month packing. So here we use the infrared radiations. So when this radiation passes through the food, so it becomes preserved for a week, month. It depends on the how much wavelength is to be passes through the packing material. Okay, that is why it is harmful for us if we use for a long time. Similarly, signal transfer from remote to TV. This is the practical application which we are used in our daily life. So in remote, we see one LED is to be there, and same LED is in our TV also. So between transmitter and receiver, infrared ray pass from remote to our TV. That is why it gets the signal and we see the TV as per our demand. Okay. Next we come to fourth one, visible part. So as we already know, because we are live in this region, so whenever we see in around the world, so it is due to only this visible part, and that is why our eye is responsible for all the colors: black, brown, red, orange, green, yellow. Okay. Next we come to fifth one. This is ultraviolet. So ultraviolet is again it is to be produced by hot bodies, or practically it is to be sun. That means the sun, this example state, if we require high temperature, so whenever a body having high temperature, it produces ultraviolet rays, and this is to be used for laser eye surgery and ozone layer. As we know, greenhouse effect. So ozone layer preservation is due to ultraviolet rays. Next we come to X-ray. So practically used we know for X-ray, it is basically used in medical purpose only. Okay, so in medical, because of high penetration power, we used for cancer treatment, and whenever we require the destruction of cells, we use the X-ray because of X-ray and gamma rays both having high penetration power. So it easily passes through our body and damage the tissues or particular cells. So in medical, we use mainly the X-ray technique. And last one is here gamma rays. So as we see here, minimum wavelength and maximum frequency. And its the main property is here maximum penetration power is for gamma rays. That is why it is to be used kill the germs in water. Okay. So whenever we use the water purifier, so in water purifier generally gamma rays to be used because it kills the germs 100% efficiently of unwanted living cells also. So this is to be practical use of gamma rays. If we talk about the production, how this gamma rays is to be produced. So in nuclear reactions, gamma rays is to be produced. Okay, so this is the spectrum, their range, their uses, and how it is to be produced. I think understood everyone. Thank you.